Welcome back. The last time I introduced to you what computer networks is, I gave you the course outline, and on your screen you can see we have about 10 outlines or 10 things that we'll be covering. Now, all these are part of the things that we'll be talking about, and I hope to teach you this one. This is just a supplementary one that I believe will give you a general knowledge about things that relate to computer network security. Now, I'll quickly delve into the lecture. And as you are aware, the last time I introduced you what computer networks is, I also spoke about the basic component that make up a computer network. We went through this particular slide, which was the network interface card or controller. And I gave some knowledge about these type of network interface card, the wired and the wireless. I also talked about what a hub is and what a switch is. I spoke about the cables, the type of cables that exist. I also talked about routers and modems and gave brief understanding of some of the uses of computer networks. So in today's, we're going to delve straight into the features of computer network. Now, outlined here are the list of computer network features, as you can see. So we have the communication speed. Let me just get the pointer. We have the communication speed, the file sharing, backup and rollback, and hardware and software sharing, security, scalability, and reliability. So anytime you hear of the features of a computer networks, these are the features of a computer networks. Virtually all computer networks should possess these kind of features. Now we're going to go into each one of them, beginning with the first one, which is the computer communication speed. Well, as you can see on the screen, we have the network being providing us to communicate over the network in a fast and efficient manner. A typical example is what has been outlined here, that when we do video conferencing or we send emails, you can imagine how the information that we try to send across to the other person or the second party waiting for the message, how fast it is for them to receive it. So the computer network is a great way to share our knowledge and also our ideas. Communication speed is one key feature of a computer network. And because of that, we are able to transfer data from one point to the other, irrespective of the geographical location. And such message or data is able to send at a faster speed. Moving on to the next feature, which is the file sharing. Of course, file sharing is one of the major advantages of the computer networks, and the reason being that it provides us to the avenue or the way to send files from one point to the other. We're able to share file amongst ourselves, amongst devices, amongst nodes on a network. I remember I explained to you that a node is any device that is on a network. It could be a computer, a mobile phone, a printer, which is connected on a network. Now, moving on to the next feature, which is the backup and rollback. It's actually made easy because of a computer network, and it's one of the important features of a computer networks. And the reason is that since most of the files are stored in the main server, which is centrally located. So, for instance, Google.com, for instance, if you try browsing for your Gmail, there's a server somewhere located centrally for Gmail users. So, if there is a little issue with that particular server, we could back it up and also have it installed on a different server. And rollback is very easy when it comes to this. So it is easy to take backup from the main server and now roll it on a different server so that we can have a continuous usage of the data that we've already sent to such servers. Now, software and hardware has been made easy when it comes to the sharing of some of these resources. mind you, the main reason for computer networking is to share network resources. So in this in this particular feature, which is software and hardware sharing, we can have less we can have an application being installed on one main server, and we can have so many users connecting to that particular server and accessing that particular application. An example could be, let's say, Facebook. Facebook, the application itself, which is a portal, is probably installed um, on a server, and we have so many people accessing that particular server to, interact with the server. So in this case, we can have an application being installed in the main server, and the users can actually have access to that application which is installed on the central server. So we do not need to install the software on every machine. And in the same vein, hardware can also be shared. So an example could be in our in an office of about 10 computers, we can have one printer which is connected onto the network, and the printer itself is the hardware. So all these computers can have access to the printer for printing. So that is the sharing of hardware. In terms of the sharing of the software, we can have a software being installed on one, and most of the clients or users having access to this particular software. For now, security is very key, which is one of the important features that comes with network. So network security usually ensure that the user have appropriate access rights to specific files and applications through various methods and technology. So in this way, the network can be configured in such a way that, um, let me give a typical example. If we have one person um, who is an administrator of a system or maybe on a website, the administrator has full privilege to do maybe updates on the site, to create users on the site, to bring new um, plugins or stuff onto the site. Now, administrator has full access. In terms of security, network security can also help the administrator to now create different access rights to different people. So we can have a manager having access to only the employees of the company, and the administrator can have access to the manager and the employees, anybody who interacts with the system. That is one key thing that also falls um, in this particular scenario. Now, in terms of scalability, as the name says, it means that we can add new components to the network. So the network must be scalable so that we can extend it by adding new devices. In this case, we can also decrease when we add new um, components onto the network. We should be ready to accept the fact that the network would also be slow. So, a typical example could be in an organization of about 10 people using a bandwidth of, let's say, um, 50 megabits per second. That is the bandwidth. And then the employees are 10. So when we increase the employee to possibly 20, we should be prepared to understand that the speed at which we were connecting to, maybe, or to the speed at which we were probably browsing, will be limited because we've had increased number of nodes on the network. And that um, increase in number would, of course, um, would bring all these people to the point where they all would have to get access to the internet. So we have to share the internet amongst them. And of course, when we create up a network, we should make it scalable in the sense that um, we could add new components onto that particular network. Now, of course, when we do add them, then it means the speed will reduce. We'll have issues with connection speed. So the problem can be overcome by using routing and switches. So as we move on, I would explain some of these things onto you for you to comprehend very well. But for now, let's stick with the simple explanation In terms of the scalability as a feature, it means the network that we will bring on board, we should be able to now add new components onto it. Reliability is also one key thing in computer networks. So a computer network can use the alternative source for data communication in case of a hardware failure. Now, most network administrators always have more like a backup somewhere in case one of their hardware fails. We an automatic route to a new server for a continuous, for a seamless or continuous access to resources to happen. So most of the network, in terms of reliability, it's one key thing that computer networks always put in place. Now let's talk about the computer network architecture itself. So the computer network architecture is defined as a physical and the logical design of the software, hardware, protocol, and the media used for the transmission of data. We're talking about the computer network architecture. That is a little different from the network topology. So in terms of the network architecture, what we are looking out for, we are thinking of is the physical and the logical design of the software, the hardware, the media, the protocol, which is used to transmit data. So in layman term, we can say that it describes how a computer and other computers get organized and how tasks are allocated to each one of them. When we talk of the computer network architecture, there are two main architecture that exists. We have the peer-to-peer network and we have the client-server network. So these are the two types of computer networks as you can see in here. The peer-to-peer and the client-server-side network. Or sometimes we say server-client network or client-server network. These are the two main types of computer network architectures. Now, talking about the first one, you can see from here, this is the peer-to-peer network. In this network, which it's a type of network in which all the computers are linked together with equal privileges and responsibility for processing data. So you can see these are all computers that have been linked together in one way or the other. So and they are linked together mainly because we would want them to have equal privileges and responsibility in the processing of data. So peer to peer, as the name says, peer to peer. When you say someone is your peer, it means the person is of the same level or qualification as you. Let me put it that way. So for a peer to peer network, it is mostly useful for small environments, usually about 10 computers. So most times when you want to set up a peer to peer network, the maximum number of computers that we normally use is 10 computers to set up this peer-to-peer computers. The peer-to-peer has no dedicated server, so it means interaction, each of these computers will talk to each other in whichever way that they want. There is no central server that is, hosting maybe an application that each of these would talk to. So special permissions are assigned to each computer for sharing the resources, but this can lead to a problem if the computer with the resource is down. So if this is meant for maybe using a special, or this contain maybe a special data, this also contain different data and so on and so forth. Each of them have different data. The moment this resource, which contain data that is used by all of these, if this goes down, then it means all these computers will be at a disadvantage because the resource is down. So that is one problem when it comes to peer-to-peer network. Now, let me go about the advantages and the disadvantages. In terms of the advantages, it is less costly as it does not contain any dedicated server. It's not so expensive. It is easy to construct. If one computer stop working, but the other computers will not stop working, of course. But if that computer that stops contain vital information, then it means it becomes a problem. So in our case, as an advantage, if any of the computers stop working, it doesn't mean the other ones would not be able to work. They will be able to work. That is about a peer-to-peer. It is easy to set up and maintain as each computer manages itself. So as I said, these are the three main advantages when it comes to a peer-to-peer network. Now, in terms of the disadvantage, in the case where the peer-to-peer network, because it does not contain the centralized system, when the peer-to-peer computer, one of the computers that contains the resource goes off, it can affect the other computers. So it cannot, we cannot back up the data as the data is different in different location. So that is a disadvantage, and it has a security issue as the device is managed by itself. So that is a disadvantage when it comes to a peer-to-peer network. Now, the client-server network architecture is the one that most institutions or organizations use. So when we talk of a client server network architecture, it's a network model designed for the end user. Most times we call the end users as clients to access a resource such as songs, videos, etc. from and so on from a central computer, which is most of the time known as the server. So the central controller is known as the server, while the other computers in the network are called clients. So the other computers that get connected to the server are what we normally term as a client. So hence we have the client server network architecture. So the server performs all the major operations such as security and network management. The server also is responsible for managing all the resources such as the files, the directories, the printers, and so on of that particular architecture. So all the clients, what they do is they interact with each other through the server. An example could be if we have client one who wants to send some sort of data to client two, then it first has to send the request to the server for permission. Then the server then sends the response to the client to initiate the communication between client two. This is how the architecture looks like. So we have, these are all clients. We have a laptop, a phone, and a desktop. And this is an internet. It could be a local area network. But in this case, you're using the internet as an example. And this is a server. So this is a server. So all these clients do not have a software. The resources that you're looking for is not on these, but on this particular server. So this is how they get connected to it. They have to pass through the internet to get access to it. And before one can even talk to this one, they always have to route their request to the server for the server to now manage it and now send it to the right person. So if this individual wants to send an email to this one, first of all send it over the internet to the server manages it and puts it up to this particular client. Let me use this as an example. So the online portal that you use to register for the semester, like the DCU student portal, so the student portal possibly might be installed on a server. Then you use your phone or your laptop to register online. So you contact the server to pull out your information and the courses that you need to register. And when that is done, it is sent back again to you. So this is the architecture of the client server network architecture. So that is how the client server network architecture also works. Of course, it has advantages and disadvantages. In terms of the advantage, a client server network contains a centralized system. And because of this, we can back up the data easily. So in this case, because we have a main server, it is easily to back up the data that is stored on the main server. And again, the client server network architecture has a dedicated server that improves the overall performance of the whole system. Usually we classify this server as, it's most of the time robust compared to this one. And usually the specification of this particular server is quite high compared to all these things. And because it's a server, it should have high specification to be able to serve all these clients when they send up requests to it. So security is better in a client server network as a single server administers the shared resources. So we have just one server, you know, um, sending resources to people, to clients that need them. For the peer-to-peer, each one of them have manage their own resource. So in terms of security, it's quite low compared to the client server architecture. In this case, we have just a single server which does the sharing of the resources. So if one client does not have the privilege to access a particular file, the server does not give access to that particular client. The next advantage is it increases the speed of sharing of resources. So you can see that from here, because all the information is stored on one computer, accessing it, we can have so many clients accessing that information at different times, and this is done at a very fast rate. So there is an increase in speed during the sharing of the resources because the centralized server now contains or manages the shared resources. For this, in terms of the disadvantage for the client server network, it is expensive as it requires a server with a large memory. As I said, the server would have to get a very good specification. It's expensive if you compare it with a peer to peer. The server has a network operating system, which is the NOS, to provide a resource to the client. But the cost of NOS itself is quite high. And finally, it requires a dedicated network administrator to manage all the resources. You need to have someone who is a network administrator to help manage the resources that are on the network, that are on that particular server side, on that particular server. Um, so in doing so, the administrator gives the right privilege to each client that comes onto the server. So we need to have a dedicated network administrator to manage all the resources. So in this case, it's not always that you'll be able to find a network administrator to help manage this. So that falls under a disadvantage for um, a client server architecture. Now, these ones, I spoke about them the last time, so more of them is going to be a recap of it. But we're now moving closely in depth into details of some of the things that goes in there. So for the computer networks, um, let's talk about the computer network components. So these are the major parts which are needed to install the software. So some important computer network components are the NIC, what I talked about, the network interface card, the switch, the cable, the hub, the router, and the modem. I explained the last time. So depending on the type of the network that we need to install, some of the network components can also be removed. We don't need to have all these things, but um, if we just need a hub to do a simple local area network stuff, then we would pick up a hub or a switch. We don't need a router unless we need it. So that is about when we talk about the computer networks. But these are things that possibly you would be employing in setting up a computer network because of it's one of them. These are the components that you need. So following the major components required to install the network, there's a network interface card, as I talked about. It's a hardware component which is used to connect a computer with another computer onto a network. So the NIC on the network interface card is what gives you access to the internet or to the network. So those are where we put the network cable inside. That device where we put the network cable inside is the network interface card. It could be wireless, it could be wired. So it's supposed to transfer most of these is supposed to transfer about 10 10,000 megabits per second. So 10 is supposed to transfer at a rate of 10 or 100 megabit per second through to 1 gigabit per second. So that is what the NIC does. So the data rates that you can get from here would be around 10 megabit per second or 100 megabit per second. And the maximum throughput you can get will be 1000 gigabits, which is 100 megabit per second. So the MAC address or the physical address is encoded on the network interface card chip, which is assigned by the IEEE to identify the network card uniquely. And the MAC address is stored in the programmable read-only memory, which is PROM. So these acronyms, you should be familiar with them. In quizzes or exam, you might be asked about some of these acronyms. So MAC address stands for Media Access Control. NIC stands for Network Interface Card. So PROM stands for Programmable Readable Online Read-Only Memory. Now, there are two main types of NICs, as I spoke the last time. These ones is just a recap again. We have the wired NIC and the wireless NIC. In terms of the wired NIC, it presents it's inside the motherboard. The cables and connectors are used with wired NIC to transfer data. So where on your computer, where you have the slot where you put in your network cable, that is the wired NIC, because you'll be using the wire to get connected onto the network. For the wireless NIC, you will need the wireless to get onto the network. So like your phone, or if your laptop has a wireless card, so that is the wireless NIC. It helps you to get access to the internet through an antenna. It contains an antenna to obtain the connection over the wireless network. An example is the wireless NIC that we have on our laptops. Now, I spoke about what a hub and a switch is. So this is an example of what a hub is. Then this is also an example of what a switch is. So usually the hub and the switches, they look so much alike, but there are differences in them. The last time I said the hubs are less intelligent compared to the switches. The switches are very intelligent in the sense that when you send data from a node to the other node, if one node is connected to this particular port and another node is connected to this particular port, a node is any device on the network. Now, if this node wants to send to this node in ports, this port wants to send information or data to this node, what a hub does is it broadcasts the signal on all of these ports. So it means all these nodes on this network will be able to possibly eavesdrop on the request or the data that is being sent. However, with the switch, if this wants to send to this, it is intelligent to directly move the data straight to where it's supposed to be. So that is one advantage about the switch compared to the hub. The switches too, we have some switches that are managed switches. It means you can, if it's a managed switch, the hubs are not managed, but most switches are managed. And managed in the sense that you can configure it in a way that you can block all the ports to prevent people from having access to your ports when they come to your network operating center. So these are some few things that you probably would have to read on to get to know the difference between a switch and a hub. They look so much alike that the switches are very intelligent than the hub. These are routers. We've seen routers all over the place. So a router usually has two network cards, two networks. So this is one network and this is also another network. So a router is a hardware device which is used to connect a LAN with an internet connection. It is used to receive, analyze, and forward incoming packets to another network. So when you look at this one, usually the ports, which is different from the other, this is the local area network for the router. A router always have at least two network cards. One of the network is for the internet or the external network, and one is for the internal network. So if you're on campus and you have internet access using a cable, the moment you are confident you have internet access, you can put the internet access here. Then configure this router to allow 4 more people to have access to this particular internet. So what a router does is it sets up a local area network and move clients on this network onto the internet. So it routes clients on the private network to another network. So that's what a router does. It moves one network to the other. It moves nodes on one network to the other. That is what it does. It's a router. So now a router works in layer 3 of the reference model, which is the OSI reference model. That is where the IP addresses comes in. So in layer 3, we can have some switches also serving as routers, or some switches also performing layer 3 duties. We'll talk about each one of them as we move on. So a router forwards the packets based on the information available in the routing table. It determines the best path from the available path for the transmission of that particular packet. So just like when you know of the when we talk about the Pythagoras theorem, we have the hypotenuse, we have the adjacent, and the angle, 90 degrees angle. So from here to here, if this is A, this is B, this is C. You know, if I want to come to A, I can move to C and move to A. But the shortest path is this, which is the hypotenuse. So in this case, that is what the router does. It takes the shortest path for the transmission of the packet that we want to send. Now, of course, the router has some advantages, and these are the ones that have been outlined in here. In terms of security, the information which is transmitted to the network would traverse the entire cable, but only the specific device which has been addressed can read that particular data. It's just like how the switches work. If I'm sending information using the router, it is not broadcasted to all the ports, but rather is the recipient of that message that receives it. So that is one advantage of the router. It's just like the switch too as well. So the information or data which is transmitted to the network will traverse directly to it will traverse the entire cable, pass through the entire cable, but only the specified device which is supposed to receive that particular request or data it will send it to that particular node. It is also reliable. So if a server has stopped functioning, the network goes down, but no other network are affected and are served by the router. So as the name says, if it is reliable in terms of an advantage. So if the server has stopped functioning, it's the server which is off, but the network, but the other networks are, but none of the other networks are also affected, mainly because of the reliability in that. So it's reliable. So in a situation where the server goes down or stop functioning, the other network are not affected. It's only the server that is down. And if all those clients or nodes on that router can still communicate with themselves, but except the server. In terms of performance wise, the router enhances the overall performance of the network. So suppose that there are about 24 workstations in a network. It will generate the same amount of traffic. This increases the traffic load on the network, but the router splits the single network into two networks of about 12 workstations each, and this in turn reduces the traffic load by half. So the router is very important when it comes to computer network. We have network range also being an advantage for a router. So we can configure a router. Most of these routers, we can use the cable and we can also use the wireless itself. So we can configure it in such a way that we can have so many clients coming into it. If we're to use the cable for this particular router, it means we can have 4 nodes on that particular local area network for the router. But we can configure the wireless part of the router to reach out to more nodes wirelessly. So we're able to cover a wide range of clients on the network. Now let's talk about the modem. These are examples of modems that virtually we've seen modems, USB modems, and all of that. We've seen a lot of them around. So a modem and a router are both essential components of most of the home networks, especially for those who have home office and also work remotely. So a modem in itself is a hardware device that allows the computer to connect to the network or the internet over an existing telephone line. And in this case, when we use the USB, the telephone line in our case is the wireless connection to MTN mast. So it means you might have to get a SIM or a chip to be placed in the modem. The modem is not integrated with the motherboard, rather, it is installed on the PCI slot found on the motherboard. We also have these are examples of USB modem. It stands for modulation and demodulation. So as the name says, modem, modulation and demodulation, or modulator, demodulator. And what it does is it converts digital data into analog signals over the telephone lines. So usually we consider modems as input device and also an output device. There are times that it converts analog signals to digital signal for computer to understand, and it can also convert digital signal to analog signals for us to also send data across to the mass of our service providers. So based on the differences in speed and also transmission rate, a modem can be classified in the following categories. We could have a cellular modem, a cable modem, a standard PC modem, or a dial-up modem. These are the categories of modems that exist. Right. Of course, to be able to have access to the network, we are still talking about the things that we need. We need cables and connectors. So cable is a transmission medium which is used for transmitting a signal. So there are 3 different types of cables which is used in transmission. These are the main ones that are available. We have the twisted pair cable, which is usually these ones. This one, these are the twisted pair cables. We have the coaxial cable. The coaxial cable they are usually the ones like for the multi-TV and so on and so forth. The multi-TV, that cable that runs from the satellite dish to modem, multi-TV modem. That is what the coaxial cables are, and the fiber optic cables. They are the ones, they are very thin. There's an example of fiber optic cable. These ones are fiber optic cable. So these are some cables and connectors that exist. The computer network types. Now, there are so many types of computer networks, but the key ones are the ones that we're going to talk about. So a computer network is a group of computers linked together to each other that enables the computer to communicate with another computer and share their resources, data, or application. So that is the main essence of a computer network. We do networking mainly because of this. A computer network can be categorized by its size. So depending on how big it is and the location, we are able to classify and know the type of computer it is, the computer network it is. So a computer network is mainly of four types. We have the local area network, the personal area network, metropolitan area network, and wide area network. So there are four main types. These are the main ones that exist: LAN, the MAN, the WAN, and the PAN. Now let's talk about each one of them. The LAN itself, so you can see this is a local area network. So in a room, in one room, if we have 10 computers and we connect it to a switch, all of them to a switch, we have a local area network. We've set up a local area network. If there is no internet in it, it becomes a local area network. So a local area network is a group of computers connected to each other in a small area, such as a building or an office. The LAN, which is termed as the local area network, is used for connecting two or more personal computers through a communication medium such as the twisted pair, coaxial cable, and so on. But most times we use the twisted pair. It is less expensive as it is built with inexpensive hardware such as the hub, the network adapters, and the Ethernet cables. So the cables, the network cards that comes with our computer, and the hub, which more like the switch. The data is transferred at an extremely faster rate in a local area network. So when you transfer data from this computer to this computer, because you are in a confined area, there is the data that's sent across the network is very fast. And the local area network provides higher security. Of course, if there are 10 computers in just one office and they are all connected together and they are not on the internet or they are not connected to any other network, information now remains still in the office. It becomes difficult to move out of the office. So hackers will not be able to infiltrate such a network unless they get these computers connected onto an external network. That is when they will be able to have access to this particular local area network. So in terms of security, it is one of the highest uh, type of network that is very secured. We have the PAN, which is the personal area network. So usually the PAN revolves around Bluetooth, the use of Bluetooth and infrared. And a personal area network is a network arranged with an individual person, typically within a range of 10 meters. So you have a laptop, the Bluetooth is on, you can connect it to this, you can connect it to a laptop, a phone, and so on. All these. This is a PAN, which is a personal area network. And most times, anytime you hear of PAN, it means you are thinking about Bluetooth and infrared. That helps you serve as a local area, a PAN, a personal area network. So you have a smartwatch on you, it connects to your phone via Bluetooth. So you've set up a PAN. The maximum range that we normally talk about is 10 meters. For the local area network, the maximum range is usually 100 meters. Because after 100 meters, we have something we call attenuation that sets up in the network. So there's a drop in packets in the network. A personal area network is used for connecting the computer device of personal use. Of course, that is what makes it a personal area network. Thomas Zimmerman was the first research scientist who brought up the idea of a personal area network. So usually the personal area network covers an area of about 30 feet, which is about 100 meters. This is about 10 meters. So personal computer devices that are used to develop a personal area network are laptops, mobile phones, smartwatches, media player, PlayStations, and so on and so forth. So there are two types of personal area network. We have the wireless personal area network and the wired personal area network. For the wired personal area network, the network is created by using USB. And for the wireless personal area network, it is developed by simply using the Wi-Fi technology such as the Wi-Fi, Bluetooth. It is a low-range network. So the moment they are on our PCs, we can have um, a personal area network, a wireless personal area network. The moment we activate the mobile hotspot on our PC, we are in the range um, of using a wired personal area network. So these are examples of personal area network: body area network, offline network, small home office network. So a body area network is a network that moves with a person, like a smartwatch. A mobile phone network moves with a person. Suppose a person establishes a connection, then creates a connection with another device to share information. So I have my mobile phone with me. I'm using a smartwatch. Once I connect my smartwatch Bluetooth to get to the phone's Bluetooth to monitor my heart rate and all, it becomes a body area network. So it's an example of a personal area network. Offline network. An offline network can be created inside the home, so it's also known as the home network. A home network is designed to integrate devices such as printer, computer, television, but are not connected to the internet. And finally, the small home office is used to connect a variety of devices to the network or to the internet and to a corporate network using what we call the virtual private network. Some of these things we'll be delving much into details when we start hitting or talking about each of the respective layers of the OSI model, reference model. Now, the next type of network is the MAN, which is the metropolitan area network. So, metropolitan area network is a network that covers a large geographical area by interconnecting different LAN to form a larger network. So, this is one LAN, there's another LAN, there's another LAN, and there's another LAN. If, for instance, GCTU has 4 campuses in Accra, they can set up a local area network in Campus 1, Campus 2, Campus 3, and Campus 4. And when all these local area network are put together, we can have a metropolitan area network. Of course, geographical area is key when we talk about, when we try to explain or let's get to know the type of network that we're working with. For a metropolitan area network, it's a network that covers a larger geographical area. For the PAN, it was just 10 meters. For the LAN, it was about 100 meters within a building and so on. So, but when we talk of metropolitan area network, it spans a larger geographical area. So usually government agencies use MAN to connect to citizens and private industries. And in MAN, various LANs are connected to each other through a telephone exchange line. It could be a telephone exchange line or a fiber optic connection or a wireless connection. So that is how a metropolitan area network works. So the most widely used protocol in metropolitan area network are what has been outlined here: ADSL, RS3, 232, frame relay, ATM, and so on and so forth. I would want you to find out what each of these abbreviations stand for. In quizzes and in exam, there's a high probability I might ask a question in that area. So it has a high range than the local area network. So that is what makes it different from a local area network. So uses of metropolitan area network, it's normally being used in communication between banks in cities. So Accra is a big place. We can have so many banks, like we have different banks in Accra. So, for instance, Ghana Commercial Bank or Fidelity Bank or any of the banks, GT Bank, just in Accra, we can have about 5 or 6 different branches of the same bank in Accra. So most times the banks use a metropolitan area network to set up such a network so that these banks at different locations or branches will be able to talk to each other. It can be used also in the airline reservation. It can be used in college within a city. It can also be used for communication in the military. So metropolitan area network is very key here. Now we have the wide area network, which we normally term as WAN for short. So as the name says, a wide area network is a network that extends over a large geographical area, such as states or countries. So we can have one country serving as one network, Ghana, Nigeria, let's say Togo. So if we connect all these networks together, we can have what we call the WAN. So there is a wide area network. So it tells you that all metropolitan area network coming together for a country and also connecting that from two different countries are linked with what we call the wide area network. It's quite bigger, it's quite a bigger network than the LAN and the MAN. A wide area network is not limited to a single location, but it spans over a large geographical area through a telephone line, fiber optic cable, or satellite links. Most times, the internet is one of the biggest one in the world. A wide area network is widely used in the field of business, government, and also education. So that is about the wide area network. And of course, it has so many advantages, as you can see here. So these are the following advantages. Geographical area. So we're able to span a wide geographical area to provide resources to different nodes at different cities, in different offices, and so on. So a wide area network provides a large geographical area. Suppose if a branch of our office is in a different city, then we can connect with them through the wide area network, and so on. We have a centralized data. So in case of a one network, data is centralized. So with the example that I gave, we do not need to buy the email files and backup servers and so on and so forth. So just when we use the MAN as an example, Ghana Commercial Bank or Fidelity or any of the bank can have their main branch, the headquarters branch, located maybe at Tesano. Then, and at Tesano, that is where the main server holding the entire clients of the bank or customers of the bank, all their data will probably be stored on a server in Tesano because that is the headquarters. So they can set up a metropolitan area network to connect to all of those. So all of the branches can now connect to Tesano branch to get information about each client that comes to their branch to transact business with them. So having that in mind, push it now out to the level of a wide area network. So it's just about the same thing. We have a centralized data. So get updated files, software company work on live servers, therefore the programmer gets the updated files within seconds. Exchange messages in one, messages are transmitted faster. The web application like Facebook, WhatsApp, and so on allow you to communicate with friends at a faster rate. We're able to exchange data and all of that. Sharing of software and resources. We can share software and other resources like the hard drive and so on. So the server containing the customer records will be situated somewhere. The other branches are able to connect to that particular server And they do so by getting access to the resource of the hard disk of that particular server. So the server, in actual fact, is sharing its resources with the other branches that gets connected to it. Global business, we can do business over the internet globally. High bandwidth, if we use the least lines for our company, then it gives the high bandwidth. So the high bandwidth increases the data transfer rates, which in turn increase the productivity of our company. So most times for a wide area network, we always go in for a higher bandwidth. Of course, these are the disadvantages of a wide area network. There are security issues. There is a need. It needs firewall and also antivirus. Because so many people will be getting access to it, so many branches will be getting access to it. We need to protect it. We need to put some sort of security measures in place that not anybody will have access to the data on the network. Specific security privileges to be given to specific people. We can't have a customer care, a teller in a bank, having a privilege of editing people's accounts and adding zeros to them. No. So these are things that, could form as security issues that might emanate on a wide area network. So we have security issues. We need firewalls to block. We need antivirus to also safeguard these servers. We need it is quite high to set up, a wide area network because of the installation costs of the one and the infrastructure that you have to put together to be able to have a very good wide area network. In terms of troubleshooting, it becomes a problem because it covers a large area. So fixing the problem is very difficult compared to the other. Okay, just a recap again. So troubleshooting problems, and that is a disadvantage for the wide area network. This is mainly because it covers a wide area. When there's a problem at any on a network, it's quite difficult to locate the problem and also fix the problem. So that makes troubleshooting a little more difficult. Now let's talk about internet work. Inter network or internet work. So inter-network. So an internet work is defined as two or more computer networks. It could be LAN or WAN or computer network segments that are connected using devices and they are configured by local addressing scheme. This process is known as inter-networking. So an interconnection between public, private, commercial, industry, or the government's computer networks can also be defined as internetworking. Internetworking is defined as two or more computer networks, could be LAN or WAN, or computer network segments that are connected using devices. They are configured by local addressing scheme. So that is what internetworking is. And usually internetworking uses the internet protocol, which is the IP. And the reference model is also used for internetworking, which is used for internetworking is the OSI reference model, which is the Open System Interconnection. So that is the reference model which is used for internetworking. Now there are types of internetwork. There are two main. So we have the intranet, and we have the extranet. So as the name says, when you say the intranet, it is an intranet is a private network which is based on the internet protocol, such as the TCP/IP. So an intranet is a private network, so within a network, within an organization. So an intranet is a private network based on the internet protocol, such as the TCP/IP, that is the transmission control protocol, and IP. An intranet belongs to an organization which is only accessible by the organization employee. The main aim of an intranet is to share information and resources among the organization's employee. And again, an intranet provides the facility to work in groups and for teleconferences. Now, GCTU can have an intranet. So GCTU's intranet is possible because it will be working on the Internet Protocol, which is the transmission control protocol or the Internet Protocol itself. And in this case, we can set up an intranet, which could be an internal website or internal application, and it's only accessible to people that are on campus, who are on the local area network of GCTU. So an intranet is a private network-based network. So it's mainly for a private institution or organization for its employees to have access to such facility that is could be an intranet. We have the extranet too as well. So an extranet is a communication network which is based on the internet protocol such as the TCP IP. It is used for information sharing. The access to the extranet is restricted by only those users who have login credentials. An extranet is the lowest level of internetworking, sorry. It is usually categorized by the WAN or the MAN or other computer networks. An extranet can have a single LAN. At least it must have one connection to an external network. So when we have an intranet for an organization and we have at least a connection to another, let's say, organization through one link, it becomes an extranet. So usually GCTU has an intranet on their main campus, and once they connect their local area network via wide area network to the other campuses, the other campuses can also now access the intranet of GCTU. So in this case, it becomes an extranet. Extranet because at least it has one connection to the external network. So that is that about the extranet and intranet. So the advantages to each one of them in terms of communication, time saving, collaboration, platform independence, and also cost effectiveness. These are self-explanatory. I would want you to go through them. And now I want us to delve straight into what we call the network topology. The network topology usually defines the structure of the network of how all the components are connected to each other. And there are two types of topology. We have the physical and also the logical topology. So for the physical topology is a geometric representation of all the nodes. And there are 6 types of network topology, which are the bus topology, the ring topology, the tree topology, star topology, mesh topology, and the hybrid topology. So when you hear of a network topology, we are more concerned about the arrangements of the components of the devices that make up the network, how they are arranged, how the structure is. So the topology defines the structure of a network of how all the components are interconnected or connected to each other. And as I said, there are 2 main types, the physical topology and the logical topology. So when you hear of the physical topology, it's more centered on the geometric representation of the nodes in the network. And the nodes is any device that is connected on the network. Ideally, there are 3 main types of topology: the bus, the ring, and the star topology. But it extends to the 6 as you can see in here, where we have the tree topology coming in, the mesh topology coming in, and the hybrid topology also coming in. So that is a computer network topology, and this is what has been outlined in here. Okay, so now for the bus topology, these are the things that makes up the bus topology. So you can see they have a network backbone, and each of these computers are connected to the backbone. And at the ends of the backbone, we have something we call the tokenizers. So now, if there is a break in the backbone, then it means the transmission of data from one point to the other, it's not possible. So the bus topology is what it does is it mainly uses the Ethernet, which is the 802.3 and also 802.4 standards for a type of to achieve this particular type of system. So the backbone is considered as a single lane through which messages is broadcast to all the other stations. And the most common access method of the bus topology is the carrier says multiple access. So this is how the bus topology looks like. Now we move on to the next one, which is the carrier says multi, still under it, still under the bus. Of course, we said it uses um, the CSMA for its it uses the CSMA protocol for its performance. So now, when you talk of the CSMA is a media access control, which is used to control the data flow so that the data integrity is always maintained. And there are two main types of it. We have the CSMA CD and CSMA CA. For the CD, which is meant for the collision detection and collision avoidance, as the name says, it's an access method used to detect the collision. So once the collision is detected, the sender will stop transmitting the data. Therefore, it works on recovery after collision. And the collision avoidance is an access method which is used to avoid the collision by checking whether the transmission media is busy or not. If it is busy, then the sender waits until the media becomes idle. Then this technique will effectively reduce the possibility of the collision. Of course, if it's busy, then it remains until it's idle before it's now transmits data. So it does not work on recovery after collision. But this one takes the risk by sending the data and colliding. The moment there is a collision detected, then it quickly recover after collision. But for the collision avoidance, it's rather checks to see if the lines are or the transmission medium is not busy. If it is not, then it sends the information. If it is, it will wait until it is idle. So that is how the bus topology works. It works using this particular technology. So the advantages to the bus topology: low cost cable, moderate data speed, familiar technology, limited failure. These are quite self-explanatory that I would want you to go through. And of course, there are advantages to the bus topology too. A typical example is what I talked about. If there is a break in the network, it affects the other computers. So extensive cabling, the bus topology is quite simple, but it still does require a lot of cabling. It's difficult in troubleshooting, signal interference, and also reconfiguration is quite difficult. And attenuation usually sets in this type of topology. Attenuation is a loss of signals, which leads to communication issues. And I said, when you use the twisted pair cable, after 100 meters, attenuation sets in. So it means there's a loss of signal after 100 meters when you use the twisted pair cable. So if you're a network administrator or a network individual who is building a network, you have to be careful the cables and the distances that you use when you're setting up this particular type of topology, either the bus, the ring, or the star topology. So we have the ring topology, as you can see over here. So you see, it's just more of a ring. It's the ring topology is like a bus topology, but with connected ends. So it means with this, all these all these devices are connected with each other. But with the bus, it's just a straight one, and the ends are terminated with the tokenizers. So the node that received the message from the previous computer will retransmit it to the next node. The data flow is in one direction, that is unidirectional. The data flow flows in a single loop continuously, known as the endless loop. It has no terminated ends. Each node is connected to each node and having no termination points. The data in the ring topology flows in a clockwise direction. And of course, the most common access method of the ring topology is the token passing. And when we hear of the token passing, it's a network access method in which the token is passed from one node to the other. The token is usually the frame that circulates around the network. So for the bus, as we spoke about, each node is either connected to the backbone cable by a drop cable or directly connected to the backbone itself. So when a node wants to send a message over the network, it puts a message over the network. All the stations available in the network will receive the message whether it has been addressed to them or not. So this makes it some more a disadvantage compared to the others. So that's about the ring topology. Of course, it also has some advantages, but before that, let's talk about the working of the token passing from here. So a token moves from the network and it is passed from one computer to the other until it's reached the destination. So the sender modifies the token by putting the address along with the data that they want to send. So the sender, what he does is, if this one is the one sending information to this, it modifies the token by putting the address, that's the location where, along with the data that it wants to send. The data is passed from one device to the other until the destination address matches. So the address was added to the data. So when it gets here, it's the same address. So once it matches it, then the token is received by the destination device. And then it sends the acknowledgement back again to the sender that indeed I have received my message. So in a ring topology, a token is used as the carrier. So these are the advantages of a ring topology. In terms of network management, faulty devices can be removed from the network without bringing the network down. We have products availability, cost, and reliable. So these are a few things that I would want you to go through. They are self-explanatory, and these are the disadvantages when it comes to the ring topology itself. Now, this is how the star topology looks like. With the star topology, usually we have a hub or a switch, and we have all these hosts connected to the hub. So that is how the star topology works. So the star topology is an arrangement of a network in which every node is connected to the central hub, switch, or central computer. So the central computer is known as the server, and the peripheral devices attached to the server is known as the client. So hence the client server network architecture. Usually the star looks very similar to that type of architecture. And in situations where you use coaxial cable or RJ45, we are able to connect all these hosts onto the central hub or the switch. So hub or switches are mainly used for connection as connection devices in the physical star topology. And the star topology itself, as you can see, this looks more like a star. It is the most widely used topology in most organizations. Virtually every organization uses a star topology because it's very easy to implement. All right, so these are the advantages of the ring. Sorry. These are the advantages of the star topology. This is the star topology. Let me get it corrected quickly. So these are the advantages of the star topology. And these are the disadvantages. So efficient troubleshooting. Troubleshooting is quite efficient in star topology as compared to the bus because, we directly connect each node to the hub. So if there is a problem with one node not receiving packets on a network, it is easy to know that this node is the one. You just have to possibly check the cable and know that the cable that connects to that particular um, node, like this one, we only if this one has a problem, we just have to check the node, and that would let us know that indeed maybe the cable is the one that is faulty and making it not accessible on the network. So network control, complex network control features can be easily implemented in the star topology, and any change made in the star topology are automatically accommodated. Limited failure, familiar technology, easily expandable, cost effective, and high data speed are all advantages of the star topology. But of course, there are two main disadvantages. We have a central point of failure. So if the central hub over here, which is this one, if this particular central hub gets faulty, then it means all these devices can't talk to each other. So that is a disadvantage. So um, the cable sometimes becomes difficult when a significant amount of routing is required. So sometimes cable routing becomes difficult when a significant amount of routing is required. Being able to route data from one point to the other sometimes is quite a little difficult. Now with this, if these are 6 hosts for this particular hub. So if you want to extend this one to maybe 14 hosts, that means you have to get a hub which is about, let's say, 14. So in that case, we'll remove one of these hosts from here. We'll connect a cable to the hub, the next hub, and we'll extend this one to move this one to the next hub that we have. We can have so many of these hosts coming together to form, to extend this particular topology. So those are the advantages. Now the tree topology, as you can see, it also looks similar to um, the bus. It's quite similar. So the tree topology combines the characteristics of the bus and also the star topology. The tree topology is a type of structure in which all the computers are connected with each other in a hierarchical fashion. The topmost node in the tree topology is known as the root, and all the other nodes are the descendant of the node. So this is the root node, and these are the descendant nodes. Root node, and these are the descendant nodes. So there is only one path existing between two nodes for the data transmission, and this is the form of the parent-child hierarchy. So you can see that is how the tree topology also looks like. Of course, it also has its advantages and disadvantage. I would want you to go through that. Then we talk about the mesh topology. So this is the mesh topology. So the mesh topology is an arrangement of the network in which computers are interconnected with each other through various redundant connections. So the key word here is redundant connection. So for instance, with the mesh topology, we can have a star connecting to each other. So we have node 1, node 2, node 3, and each of the nodes are connected to each other. So this is connected to this, and connected to this, and connected to this. So only node 1 is connected to node 2, node 4, and node 3. Node 3 is connected to node 1, node 4, and node 2. So we set up redundant connections in a mesh topology. There are multiple paths from one computer to the other. It does not contain a switch, the hub, or any central computer, which acts as a central point of communication. So the internet is an example of a mesh topology. So in this case, it's mainly used for wide area network implementation where communication failure are a critical concern. So recently, when the internet went down, we were routed to South Africa also to be connected onto the internet. So the internet usually uses the mesh topology. So when one of the network goes down, so for instance, node 1 is connected to node 3. If node 1 to node 3 connection gets broken, like this one goes off, node 1 can still send to node 3 because it can send it to node 2, node 2 will send it to node 4, and node 4 will send it to node 3, or directly send it to node 4 and to send it to node 3. So there's a break in one does not affect the transmission of data. So the mesh topology is mainly used for wireless networks. The mesh topology can be formed by using this formula. The number of cables n times n minus 1 all over 2, where n is the number of nodes that represents the network. So that is about the mesh topology. Of course, it's divided into two. We have the full connected mesh topology and the partial connected mesh topology. As the name says, for the full, each computer is connected to all the computers available on the network. So like this one, each of the computers is connected to all the computers that are available on the network. But for the partial, not all, but certain computers are connected to those computers with which the communication is quite frequent. So if I talk to you always, then I establish a connection with you. So in this case, if node 1 does not talk to node 4 a lot, they will not establish a connection with this. So it becomes a partial mesh topology. So these are the two main types of topology, partial and full mesh topology. Of course, there are advantages and disadvantages to them. These ones are self-explanatory. I would want you to go through it. Then we have the hybrid topology. So the hybrid, as you can see, we have the star topology, the ring, and the bus. So a combination of the different topology is known as the hybrid topology. That is what you see here. And the hybrid topology is a connection between different links and nodes to transfer data. So when two or more different topologies are combined together, it forms a hybrid topology. And if similar topologies are connected with each other, we will not call it as a hybrid topology. It has to be different topologies. The moment we have different topologies connecting to each other, it becomes a hybrid topology. So if we have two-star topology coming together, it doesn't form a hybrid topology. It has to be different network topologies. So example, if there is just a ring topology in one branch in any bank and a bus topology in another branch in maybe Fidelity, let me use our main bank, TCB. So if we have a ring topology in one branch of a bank of GCB and a bus topology in another branch, connecting these two will result a hybrid. But if it's of the same ring topology, then it's not a hybrid. So these are the advantages of the mesh topology. And now, there are some few things that I want to talk about. Now, the transmission mode is very key. It's one thing that we have to always have in mind. So the way in which data is transmitted from one device to another device is known as the transmission mode. So it's sometimes also known as the communication mode. Now, each of these communication channels has a direction associated with it, and the transmission media usually provides this type of direction. So in this case, we can have a transmission media known as the directional mode. A transmission mode, which is known as the directional modes. And most times, the transmission mode is defined as in the physical layer. And when we start with the OSI model and talking about each one of them, you realize that before the transmission modes can, when it does start, it's actually starts at layer one, which is the physical layer. So the transmission mode is divided into three categories: the simplest, the half duplex, and the full duplex. When you hear of the simplest, we're talking about transmission. That is data being transmitted from one device to another. That is the transmission mode. And we are saying that this particular transmission mode can be divided into three different categories: the simplest mode, the half duplex, and the full duplex. When you hear of the simplest mode, in fact, it's just like sending data in just one direction. So in the simplest mode, communication is unidirectional in one direction. The data flows in just one direction. An example is, for instance, when you tune in your TV to TV3 station, data is received directly from TV3. You don't interact with the data. So the only thing that you can do is to watch TV. And in watching the program that is being broadcasted by TV3, let's say Date Rush, then it means you don't interact with Date Rush. The only thing you can do is to watch what TV3 is broadcasting to you. So in this case, data is being sent to you or transmitted to you in a simplex mode. So data communication is on unidirectional. So the data flows in just one direction. So devices can only send the data but cannot receive. So they can only send it to you and we only view what is there. We can't do anything about it. So that is about it, about the simplest modes. The radio stations is also a simplest channel. When you tune in your radio to any of the frequencies or FM stations, what they transmit to us is in one direction. We can't interact with the data that they send to us. We can only listen to it. So that is about the simplest mode and the advantages and disadvantages to it. So the station can usually only utilize the entire bandwidth of the communication channel so that more data can be transmitted. Because they are the only ones sending information, they're able to use the entire bandwidth to send that particular information. So this is an example. So transmission is in only one direction. This sends information only to this one, and this can't do anything about it. So communication is unidirectional, so it has no intercommunication between devices. So it's only this computer that can send information to this computer. That is an example that we can give. Now we have the second one, which is the half duplex. So the half duplex, in fact, data can be transmitted in both directions. So in that case, this computer can send information to this computer, and this computer can also send information to this computer. So transmission is in either direction, but not simultaneous. So the moment this sends computer information to this one, this has to wait for the information before he can also send. Both of them can't send the same information at the same time. It has to be one at a time. An example is the walkie-talkie that has been outlined over here. So, for instance, we have, assuming we have two people using the walkie-talkie. If I want to talk to anybody in the class, if somebody in the class also has a walkie-talkie, and I also do have a walkie-talkie, and we are on the same channel, if I want to talk to any of you, I would have to pick the walkie-talkie, um, speak, and everybody speak to the walkie-talkie. Then when I'm done, I will say over. Then I'll lock it. Then whoever is supposed to receive the information, if I mention the person's name, he will also pick up the walkie-talkie, respond to me, and also tell me, say it over the response that's over. So whilst he's talking, I can't talk. It's after he sends the information to me, that is when I'm able to also talk. So that is how the walkie-talkie works. So we both can send or transmit data or communicate with each other simultaneously. We have to do it one at a time. So there are advantages and also disadvantages to that. So those have been outlined over here. Now we have the next one, which is the full duplex. With the full duplex, we can transmit information or data in both direction and simultaneously. An example could be like the WhatsApp application. Whilst I'm sending a message, you can also be sending a message, and we can all receive the message at a time. Or if I call you on phone and we are talking, whilst I'm talking, you can also talk. So that is how the full duplex mode works. The advantages and also disadvantages to it, and those are what have been outlined here. Now the table over here outlines the differences between the simplex, half duplex, and also the full duplex. I would want you to go through it and understand each of them. It's quite self-explanatory. The next time we meet in class online, we will have a quiz. So I would want you to go through it and get yourself ready for the first quiz. We are done with the first chapter of the outline that was given. So we are done with the first chapter. We'll move on to the models the next time. These ones are not quite voluminous compared to the others. So we will finish quickly. So get yourself ready, and we will hold our first quiz about 30 minutes into the first time that we meet. So make sure everybody will be online at the time. We'll meet in class. I'll tell you the time, then you start with the quiz. So get yourself ready for the quiz. All right. So thank you very much. Usually in class, I would have asked one or two people to summarize what you've learned, but because this is a recorded video, I'll leave it up to you. Thank you. If you have any question, prepare it and let's meet next week and we would discuss it. Thank you very much.